Still on the cache mapping techniques, I will talk about effect of hit ratio on average access time and cache in virtual memory systems. Effect of hit ratio on average access time. Hit ratio represents the portion of memory accesses found in a cache. Also, the hit ratio is a measure of the effectiveness of the cache memory in serving requests from the CPU. Cache hits. It is the percentage of requests that are successfully retrieved from the cache. It occurs when the CPU requests data from the cache memory and the request is successfully retrieved. An example is if a website receives 100 requests and the cache serves 80 of them, the hit ratio is 80%. Cache miss. A cache miss happens when the CPU requests data or instruction from the cache memory, but then the requested item is not found in the cache. Since the requested item is not found in the cache, it cannot be retrieved, which then becomes the vice versa of the cache hit. Average access time. It is the average time it takes to retrieve data, considering both cache hits and cache misses. Effect of hit ratio on average access time in terms of performance. When the hit ratio is high, it leads to faster loading time for users as data is retrieved from the cache. When the hit ratio is low, it results in slower loading time as more requests requires accessing the slower origin server. In terms of resource utilization, when the hit ratio is high, it reduces the load on the origin server as it's handling fewer requests when there is no strain on the origin server. When the hit ratio is low, it puts more strain on the origin server, potentially requiring more resources to handle the increased load. Factors affecting hit ratio, which then causes an effect on the average access time. 1. Cache size. Large caches can store more data, potentially leading to a higher hit ratio. However, excessively large caches can also lead to increased memory usage. Cache invalidation. If data is invalidated too frequently, it can lead to a lower hit ratio. How data is updated or removed from the cache is very crucial. Access patterns. Frequently, access data is more likely to be found in the cache, resulting in a higher hit ratio. The formula for finding average memory access time. The average memory access time can be calculated using the following formula. Average memory access time is equal to, into bracket, h times tc plus another bracket, 1 minus h times tm, where h is the hit ratio between 0 and 1, tc is the cache access time, and tm is the main memory access time. Also, the formula for hit ratio is equal to hit divided by the hit plus miss, where the hit is cache hit and miss is cache miss. In conclusion, the higher the hit ratio, the lower the average access time, and vice versa. Now to the cache in virtual memory system. Virtual memory. The virtual memory uses virtual addresses mapped to physical memory via a page table, where the page table is a data structure that maps virtual addresses used by processes to their corresponding physical addresses. Cache. The cache stores frequently accessed data to speed up memory access. The purpose of a virtual memory is to extend the apparent size of main memory by using disk space as an extension of the random access memory, the RAM. And the purpose of the cache is to speed up data by storing frequently used data closer to the CPU. sometimes in multiple levels. The cache can be integrated in this architecture in primary ways. 1. Virtually indexed virtually tagged cache, VIVT. The VIVT cache uses virtual addresses for both indexing and tagging. The VIVT cache is faster as it avoids address translation before access. The VIVT cache is prone to aliasing problem, which is same physical address maps to multiple virtual addresses. The second primary way is physically indexed, physically tagged cache, PIPT. Cache access happens after address translation, point 1. And point 2, PIPT cache ensures correctness and consistency. Point 3, PIPT cache is slightly slower due to translation overhead. The third primary way is virtually indexed physically tagged cache, VIPT. The VIPT cache is a hybrid approach. Under the VIPT cache, indexing is done using virtual address, which is fast, but tagging is done with physical addresses, which is accurate. Point 3. Most modern CPUs uses this method to balance speed and correctness. Cache and page tables. When there is a cache miss and data must be fetched from main memory, the system may need to consult the page table to translate the virtual address. This can introduce extra delay unless a translation loop-side buffer (TLB) is used to cache recent translations. The role of translation loop-side buffer. Translation loop-side buffer hits has fast address translation. Translation loop-side buffer miss requires page table work, which increases access time. To conclude, thus both cache hit ratio and translation loop-side buffer hit ratio are critical to minimizing the effective memory access time. Thank you.